Hello everyone, welcome to another video. Khatveya chu kinematics portion jaws ya bonai bolcher ten. We are going to proceed to the next chapter of class 11 physics, that is the laws of motion. Okay, Newton's laws of motion. So in this video we will discuss only the three laws, and then we'll solve some questions based on those three laws, and then in the subsequent videos we'll do the rest of the topic. Okay. Newton's laws high school so we have three laws, so we'll go through them one by one. So the first law is everybody knows this. So the first law is every body continues to be in a state of rest or in uniform motion in a straight line unless compelled by some external force to act otherwise. Because suppose in a table chunga ko box khara ko icho chu khumi dang kui masan aga su lo wala chun tai dan ni cho, so it will stay there forever. Okay, so it says so first law is basically that one unless there is some external force applied to an object. Okay, masanga ngi banga so na jing ni cho. See, another way of saying first law is if the net external force on a body is zero, net force on a body is zero, so then its acceleration is zero. Acceleration zero, you have to imagine that there is no force on the object, so that means it is not moving. Okay, acceleration can be non-zero only if there is a net external force on the body. So I have given here one more. If the sum of all the forces net force so every force that is acting on a body, right? So the total force is the net force. So if the net force, the sum of all the forces acting on a particle is zero, then only then the particle remains unaccelerated. Unaccelerated, a equals to zero. Na acceleration to zero. Acceleration zero, you have to assume that the particle is at rest, okay, or it is moving with a constant velocity. Now acceleration zero to the palom constant velocity palom you know the formula for acceleration. A is what? dv by dt. So a0 means v, dv by dt is zero, that means v is constant. Okay, so dv to v final minus v initial by t. So t final minus t initial. So if this is zero, then what is this? So here you'll have v final equals to v initial. So this is the case of uniform velocity. Okay, so the velocity is not changing with time, right? So here you have to make one conclusion that if acceleration is zero, okay, if net force is zero, acceleration is zero. If acceleration is zero, then velocity is uniform, right? Constant velocity. Or another case is the particle or the body is at rest. Okay, so here it is also written a equals to zero if and only if f equals to zero. Okay, video masacho frame of reference bolna. If you see the last two videos, amasa pacho relative in 1D bolva and ina pacho relative in 2D bolna. Kutile relative motion poimo relative motion up poimo tilkhachu bihamtile frame of reference. Huila parano ma huila no observe na. So from where are you sitting, and then while you're observing the motion. Okay, so the position of observer, so the place where the observer is sitting, right? So that is the frame of reference. So here you see the concept of rest, motion and acceleration is meaningful only when a frame of reference is specified. Examples on copy. Suppose you are in an elevator, so which is moving upward, okay, and there is also another elevator which is moving with the same acceleration as your elevator speed kibanga achi tawala chun. So with respect to you, that elevator or that lift is at rest sang laudicho as you speed kibanga achi to honji asana. But if you look it from the maybe the ground, from ground somewhere else, you will see that both of the elevators are moving upward. Okay, so that elevator, so which you are observing, is also moving up with the with some velocities. Okay, with respect to the person in the ground, but with respect to you, it is at rest. So from where you're watching, from where you're observing is important. Okay, so that is the frame of reference. So Newton's first law is valid in one frame of reference, but it may not be valid in another. Okay, valid kiti chu pe ha ki apply the na first law chu ki apply the ti ne chu. So the validity of Newton's first law depends on the frame of reference from which the observer measures the state of rest, motion, acceleration of the particle. To aka say ta banga chu na nangin lift chelai kuna lift dang khat na vet ala chun nanga dinga chu lift pa chu chang lo pichula na, it is rest with respect to you because you are moving with the same uniform velocity. Okay, but with respect to somebody else on the ground, so that lift is going upward. So it depends on which frame you're watching. Okay, a frame of reference in which Newton's first law is valid. Okay, so that frame is called inertial frame of reference. A frame of reference in which Newton's first law is not valid is called non-inertial frame of reference. So here I will give you only one thing. Inertial frame of reference. Na inertial frame of reference should be dinaham. So it means that the frame of reference, so the frame from where you're observing, na vet na pacho, no na frame pacho. So that is either at rest, okay, or it is moving with constant velocity. Frame of reference pacho na. So if that frame of reference is either at rest or it is moving with constant velocity, only then you can say that that frame of reference is inertial frame of reference. Okay. Otherwise, if it is accelerating, okay, if it is accelerating, then that frame of reference is not an inertial frame of reference. So we call that non-inertial, okay, non-inertial frame of reference. Okay, so you have to chelaya a difference pattern na. Inertial frame of reference so the frame of reference is either at rest or it is moving with constant velocity. Okay, and non-inertial frame of reference so that the frame of reference is accelerating. Okay, if it is accelerating, so that frame of reference is non-inertial. Okay, so that much. So we have discussed already. So A equals to 0, F equals to 0. Example kapita. Suppose I have a object on a table. Table so my box khat cho koi masana su kha lawala chun chi box pa chu achunga so dan na. So with respect to you, if you are standing on the ground and then looking at that box, you'll see that that box is not moving. Okay, it is at rest with respect to you. But what happens when you watch that box from somewhere outside the art, outer space? Art so the art is moving, it is rotating. Okay, so that means if you're watching from outside the art, you will see that that box after some time it will have moved, it will have rotated some distance. Art pula kona vilauchun box pa chu res am hi beta. Okay, but if you are sitting on the ground here and then looking at that box will be at rest with respect to you. Okay, so this is true. Okay, if the art is the frame of reference, so the frame of reference is in the art itself and looking at that box. Okay, only then A equals to 0, F equals to 0 is right, it is possible. Okay, so that much in first law. Abana second law. Second law chupiham, the rate of change of momentum of a body is directly proportional to the applied force and takes the direction of the force. So it is basically force is equals to rate of change to divide by time. Na per unit time is rate of change. So d momentum divided by dt. Okay, so F equals to dp by dt. This is Newton's second law. Na. And from here, see what I can do is F equals to dp by dt. Picho momentum is all langle second third video langle involved na chila hi. So what is momentum? Momentum formula is m into v bar, m into v. Okay, so mass into velocity is the momentum. So if I take out the mass constant, I will have dv by dt. So what is dv by dt? Acceleration. Okay, so what do you have? Force is equals to mass into acceleration. Okay, So Newton's second law is not force into equals to mass into acceleration. It is the rate of change of momentum. So the rate of change of momentum is directly proportional to the applied force. Okay, so that is NCERT definition of Newton's second law. Okay, so from here, what you can do is acceleration. If you transfer the mass on that side, you'll have force divided by mass. Okay, so this is what is basically written here. Okay, in this definition. So the acceleration of particle as measured from all inertial frame is basically the vector sum of all the forces. So the net force divided by its mass. Next, you have the third law. Third law, everybody knows this. So to every action, there is always an equal and opposite reaction. Suppose if a body A exerts force F on another body B, then B also exerts the same amount of force on A but in opposite direction. Okay, so here if you see, if A exerts F, then B exerts minus F. So minus in vector means opposite. Okay. Example aja beta. Suppose chilai bang cho na bang ahi box khat cho block khat. So this block, if you push by some force F, you will see that the block is not moving. Okay, the net force is 0. So why? As later on, next video we'll learn what is normal forces. So here the wall is also applying another force called a normal force. Okay, so here this F and N, they are basically the magnitude pass na kibang chad. So there, if F is 10 Newton, so here the normal will also be 10 Newton. Okay, so the magnitude of the two force will be same, but you see F pa hinzi langa up asot chulana, normal pa langa asot v langa asot chulana. So they are in opposite direction. Okay, so one basic example of Newton's third law. So to every action there is always equal and opposite reaction. Let's jump into problems. Okay, so we'll solve some problems related to Newton's laws, right? So first law, second law, third law. So we have learned about inertia, inertial frame of reference, non-inertial frame of reference, right? Okay, let's solve some questions on that one. Okay, so question number 1. You have a reference frame attached to art. Okay, a reference frame attached to art. So the reference frame is attached to art. Okay, so what are the possible options? Is an inertial frame by definition. Reference frame khat chu art to ake manala chun na. Ake su kha ala chun chi frame pa chu inertial frame ahidam. The art is revolving around the sun. Okay, I'll draw like this. So this is the sun, and let's say this is the art. We all know that the art is revolving around the sun. So when it is revolving, so what type of force do you experience? A part is circular, elliptical, but it is, you can apply circular motion concept here. Okay, so here in other later videos we're going to learn something called centrifugal force. Okay, so here the art experiences some force called centrifugal force. So this force acts on everything on the art. Okay, so see, if you have a force of malachun, force ma, so force equals to ma, that means there is some acceleration. Okay, so the art has some acceleration. So you say the art is also rotating around its axis, its own axis. So when the art rotates around its own axis, it be force. So when the art is rotating about its own axis, so you also have, see, his circular motion. Okay, everything on the art also experiences this force, which is a centripetal force. Okay, you can also say force has a centripetal force, centrifugal force is force of gravity is also there, right? So force of gravity is also there. So within the art also force of gravity is there. Okay, force of acceleration okay. If force is equals to 0, acceleration is 0. If force is not equals to 0, then acceleration is not 0. So that means if the art is since the art is revolving around the sun, so we cannot say that the art frame is inertial frame. Okay, so first thing. and since the art is rotating about its axis, so it is not an inertial frame. Okay, so B and D are the answer. So next question. A particle stays at rest as seen in a frame. Frame khan ako na so particle nevet chula na. So nevet ala chun, so you saw that the particle is at rest. So what can you conclude? So the frame is inertial. So is it possible? Itayam. Abul lang pia elevator problem example ka pi chula na. So if you have two elevator, okay. So you are say A and B, you are at B, okay. To you, a box, so let's say both of them are moving with same acceleration A, okay. So here to you, the block on A will be at rest, okay. So to you, you are at B, you are looking at A, so to you, the block at on A, elevator A will be at rest, and nangum na elevator pa to acceleration iya chi chula na. If you have acceleration, that means that frame of reference is a non-inertial frame, okay. So that means the first is wrong. What about the second one? The resultant force on the particle is 0. It's possible na. First law of resultant force 0 here as an acceleration to 0 abana particles to rest chula na. Okay, so this is possible. Okay, this is possible. Let's see. Abana to see to the frame may be inertial, but the resultant force on the particle is 0. Hichivang simple. See, a simple block is resting on a table, so you are watching that block from the ground na. Nangom na ground to inertial frame chula na. Abana block pass on so rest out malachun, so the resultant force on the block is also 0. Okay, so that means the third option is correct. So this is properly correct. Fourth, the frame may be non-inertial, but there is a non-zero force. Here's an example pi. Frame pi has a frame pi non-inertial na. Abana chalai leaf pi hivilachun. To a block hitalo leaf pi hivilachun. Leaf pi chunga hi net force so since there is a net force, that is why the leaf is moving with A. The leaf has some acceleration. Okay, so the frame of reference is also non-inertial, and the leaf also has some net force. Net force is not equals to 0. Okay, so that is one case. So D is correct. So from the fourth option, you can see that so it stays at rest in a frame. Okay, see, it is also possible that the frame is non-inertial. Okay, if the frame is non-inertial, then the resultant force on the particle is equals to 0. Is it possible? See, if the frame is non-inertial, okay, so the resultant here is not equals to 0. Okay, resultant force is not equals to 0. If I'm B na hivilachun, resultant force is equals to 0 kitichula na. So there is a case when this option is wrong. Adi na zong na jipen hi, adi lo na zong jipen hi. To chi case ha hivilachun, frame to non-inertial frame hiya na. Hi lift pa chung net force malachun, net force amazon A to not equals to 0 chula na chila hi. Net force is not equals to 0. So if we take the frame as non-inertial frame, then the resultant on the particle need not be 0. Okay, may not be 0. So in this case, so therefore B part is also wrong. Okay, so the answer is C and D. A bullet moving 250 meters per second penetrates 5 centimeters into 3 limbs before coming to rest. Find the magnitude of retarding force exerted by the tree on the bullet if the mass of the bullet is 10 grams. So a bullet went in. Okay, so it went in. So when it enters, what was the speed? So speed is 250 meters per second. Na alud na chung. Kutile alud zawa chu distance is at a cover zawa. 5 centimeters a cover zawa hi. Now it comes to rest. Okay, bullet chu kinga ta chu. A kinga la piham. So final velocity is 0. Okay, what is the initial velocity? 250. Question force retarding force. Retarding force will be mass into acceleration. Okay, mass into retardation. Retardation no sizing na. So you need to find out what is the retardation here. You have v, you have u, you have x, you have a. So you can use v square minus u square equals to twice as, right? So you solve this, how much you get? V square is 0. 250 square equals 2. 2 into a into distance of 5 into 10 power minus 2. A is ang podium. So a will be equals to minus 250 into 250 divided by 2 into 5 into 10 power minus 2. Chilaya minus ha. You have a minus here. It shows that it is retardation. Okay, it just tells you the direction. So 5 are 25. Okay, let's do it like this. Here 5 2 are 10. It's 10 na. So this 10 and 1 0 gets cancelled out. Remaining na. So 25 square is 625. So 6250 into 10 square. Okay, so I'll just keep it like this. So this is meter per second square. So here retardation. Now retardation so tayo balance p hold force hold na. So therefore, what is the retarding force? Mass to that mass into acceleration. Mass to 10 in gram, kg as 10 power minus 3 into force to 6250 into 10 square. Sila minus ko ilo ta minus to retarding a ti head na may sana. So here what I can do is the 0 tomgumza into 10 power 3. Okay, so these two gets cancelled out. So finally I will have 6250 Newton. Okay, so this is the retarding force. Next question, the force on mass 10 gram is given. The force kipi na mass on kipi. It starts from rest. Kotela u0. What would be its position in time t equals to 5? Force evaluation 10 I cap plus 5 z cap. Force to mass into acceleration. So mass into acceleration will be 10 I cap plus 5 z cap. So acceleration will be mass to that 10 gram na 10 gram. So that means 10 divided by 10 into 10 power minus 3 I cap plus 5 divided by 10 into 10 power minus 3 z cap. Is that how put them? 10 cancel. So 1000 I cap plus 10 power minus 2 500 z cap. Betang motion into d ball also na motion into d. So so this is ax. So what is this? This is ay. Okay. So both in x and y plane, right? So there is motion into d. So what is the position? It's the position on times on kp. Okay, it starts from rest, so initial velocity is 0. Okay, let's find out. First, along x-axis. Along x-axis as time t equals to 5 seconds also is zanlunga. So x equals to ux into t plus half into ax into t square. Ux 0, okay. Half into ax to that 1000 into times of 5 square. Is that 5 25 by 2 to 125. Okay. So you will have here how much is this? 500. So 12500 meter. So along the y axis lang also 5 seconds awacho. Y equals to uy into t plus half a y into t square. Uy 0 half into 500 into 5 square. Is that the answer? So 5 for 25 into 5 is 125 12500. So divided by 2. 2 6 are 12. 2 2 are 4. 2 5 are 10 meter. Okay. Kutila final position so final position is 12500, 6250. Coordinate na. This is vector vector. So final position displacement is equals to 12500 I cap plus 6250 z cap. Okay, so this is the final position. Next question. An object with mass 500 gram moves along x-axis with speed speed is kpm 4 root x. The force acting on the object is force kpm force to mass into acceleration. Okay, always na Newton's second law. Let's p kp mass kp a acceleration kp law na. V kp acceleration it no. So we know that acceleration equals to dv by dt. Okay. See, there is one formula between acceleration and velocity. Okay, and x. So there is a formula a equals to v dv by dx. So just simply remember this formula. Derivation of ball. So remember this one. V dv by dx is also acceleration. Okay. So here I'm going to use this one. V kp who is that so v is given as 4 root x. Okay. So 4 root x means x power 1 by 2. So here this is v. So what will be the dv by dx? Variable to x function to v is dv by dx will be, so how much is this? 4 1 by 2 x power 1 by 2 minus 1. Okay, that means how much? Minus 1 by 2. So you'll have here minus 1 by 2. So this is how much? 2 or 4. Right, so 2 divided by root x. Okay, so this is the value of dv by dx. Okay, now I have dv by dx. I also have v. Acceleration. So what is acceleration? V2. So 4 root x. Okay, into, see these things. So v into dv by dx. Okay, I can write like this. So this is v2 4 root x dv by dx. So 2 by root x. Okay, so root x gets cancelled out. So how much is this? For 2 are 8 meter per second square. So this is your acceleration. Acceleration bana mass na. Therefore, what is the force? Mass into acceleration. Mass of 500 into by 1000 na kg into 8. Okay, so how much is this? So 1 2 3 4. So 5 8 are 40 by 10. Okay, so you'll have 4 Newton. So here is Zamen's question. Okay. Next question. Question number okay, so try edit so just edit yourself. Okay, just make a somewhat modification. A body of mass 4 kg experience to force niyum. Okay, question should be the acceleration of the body. Net for Newton's second law formula of F equals to ma F. So what is this F? So this F is the net force. Okay. Theory is F is a net force. So sum of all the force. So the vector sum of all the forces. See, I'll just show you again. The vector sum of all the forces. Okay, so divided by the mass will give you the acceleration. So the acceleration of the particle is given by the vector sum of all the forces divided by its mass. Okay, so here if we apply that one here, okay, so where is that? So here, right? So what is the vector sum of all the forces? So this quantity, right? So this is the vector sum of all forces. Okay, so that means F net will be equals to force is force 1 plus force 2. Okay, force 1 is 5i plus 8j plus 7k. Plus F2 to 3i minus 4j minus 3k. To solve the 5 plus 3 to 8, 8 minus 4 to 4, 7 minus 3 to 4. Okay, so this is the net force. Acceleration to piham. Therefore acceleration will be equals to, so the net force divided by is that mass. Mass to divide out. So acceleration will be equals to force by mass. So that means 8i plus 4j plus 4k divided by mass is that 4 kg. So for 2 are 8 plus j plus k. Okay, so this is the acceleration. 2i plus j. So first option. Okay. Let's do one graph question, and I think this is the last problem. A particle mass to 50 gram moves in a straight line. The variation of speed with time, speed versus time ki pi na jala v versus t. What is the force acting? Batang force acting at t equals to 2, 4, 6 ki pi. So jala force to pi mass into acceleration. Okay. Abana acceleration to pi so dv by dt. Na dv by dt ki jipa la chun pitina dv by dt cho. So dv by dt means in a v versus time graph, the slope, okay, the slope dv by dt is the slope, is the acceleration. Okay, so in the graph you look at here, hitting the arm a, b, c to d na. Khotile a apat b chan hi chun straight line na slope ki angle ki bang chuna chi chalai slope is at ha. So let's say this one is m1. Slope to acceleration chula na chi. So let's say this is a1. Is that the slope to dy by dx. Okay, dy is that 15 minus 0 to 15. 15 divided by x lang to 3. Okay, so this is 5 meter per second square. Abana to a2 chipai a2 tiu a2 to that so here you see the line is parallel with the x-axis. Okay, and the line BC line part to x-axis evaluation angle is 0 so that means the tan 0 is what? It is 0. So slope is 0, acceleration is also 0. Okay, in the second part, let's say this is a3. A3 is at so whenever you have a line like this, okay, this is a negative slope. It shows us here graph kinematic portion of graph eyeball side. So if you have trouble understanding this, please go back and watch those videos. AB part here. So if a line is like this, so this is a positive slope. If a line is like this is a negative slope. So that 15, that 3. Okay, so 8 minus 5 is 3. So you have the same thing 15 by 3. So that means 5. Now you'll have minus. It is a negative slope. Kutile force chuna. Hechilanga force by positive heading. Hechila mass into acceleration and mass into acceleration to force na chila force 0 heading. Hila negative acceleration to retardation tinenza. So you will have a retarding force. Okay. Time equals to 2. 2 seconds to so this lined. Okay, so this slope. 4 seconds to 4 seconds is this. So this lined. Okay. 6 seconds means this part. Right? Okay, so that's right here. At t equals to 2. Right, so what is the force? Mass into acceleration by 1000 into acceleration to 5. So how much is this? 5 25 250 by 1000 means 0.25 Newton. Okay, at t equals to 4, so force equals to how much? 0. Mass into acceleration 0 so na bc ako. And then at t equals to 6 seconds, force is at the so mass to 50 by 1000 into acceleration to minus 5. So this is minus 0.25. So this means a retarding force. Okay, so that much Newton's first law, second law, third law. Okay, and some questions related to those 3 laws. So video kit palehun, we have to do free body diagrams and then different types of forces. Okay, we have normal, we have tension, we have friction. So we are going to do those things in the next video. So this much. Okay, I hope you understand. See you in the next video.